Hey, Compact students. This is Miss Moyer. We're going to talk about section 11.7, dilations. If you look at the picture that we have here, we've got two sets of eyes. And if you've ever gone to the eye doctor, you might have had some drops put in your eyes that dilate your eyes, and that helps the eye doctor to see more of what's going on in your eyes. If you've ever come out of a movie theater on a sunny day, you've had that experience where your eyes hurt and it takes a second to adjust. That's because your pupils need to dilate to the right size to let in the right amount of light so it doesn't hurt. In math, a dilation is a transformation in which a figure is made smaller or larger with respect to a point called the center of dilation over here. So notice that from the center of dilation, there's these straight lines stretching out, and that both our figure and image are touching those lines. Okay, if you've got your notes packet printed out on page 15, you'll see this activity. And I'm going to ask you to take a minute, pause the video, and write down the coordinates of the vertices of the shaded triangle and the coordinates of the vertices of the non-shaded triangle. Okay, I filled in these ordered pairs for you, and I want you to take a look quick and see if you notice any connection. In fact, let me draw in a few lines, and I want you to see if that helps with your connection. Okay, so notice the blue lines I drew that connect the origin to a point on the shaded triangle and then continue right out to the not shaded triangle. So this hopefully is helping you see that we're looking to connect those 2 points and how they're interrelated, these 2 points, how they're interrelated, and the last two, how they're connected. Think about it for a sec. Hopefully you're starting to see that the points have been tripled. And that's really how straightforward dilating something is. You take the ordered pair and you multiply it by some number, some constant, and you end up with a new figure. That's the dilation. Okay, example 1. I think you have to skip a page to get up to here in your notes. It says, tell whether figure B is a dilation of figure A. So hopefully you can see for part A here that these look like dilations. The way to really tell is to draw those same lines I did before. So I'm going to pause for a second and draw those lines. Okay, so you can see those 3 lines connect together back here, and that is going to be the center of dilation. This is a dilation. This is a yes. So for B, maybe they are. They look very similar. Maybe one's just slightly different. So let's do the same thing with the line drawing to see what's exactly happening. And hopefully you can see that my lines that I drew are parallel to each other. So this is actually a no. This is just a translation. You have this definition in your notes, and I want you to take away a few things from it. First, this phrase here, scale factor. We've seen that before in other topics from 7th grade. And it's the number that you're multiplying a figure by to get the image. And we're going to abbreviate that scale factor by a fairly familiar constant letter, K. So really, if you're dilating, you just take an ordered pair and you multiply both the x and y coordinates by your constant. Important to note, when K is bigger than 1, you are going to get an image that is bigger. It's called an enlargement. That's the same words that you'd use in Photoshop. If K is bigger than 0 but less than 1, it's going to get smaller. It's called a reduction. I've lost the N, but there's a reduction. Okay, so example 2, let's actually do a dilation. So we've got this triangle ABC, and it says to draw the image of triangle ABC after a dilation with a scale factor of 3, and identify the type of dilation. So first, scale factor is 3, so think for a sec, is it getting bigger or getting smaller? Hopefully you're thinking through it's going to get bigger. That's called an enlargement. Okay, so we've got an enlargement. And all we have to do is take the original points and multiply each by 3. So it's going to be 3 times the original 1, 3 times 3, or 3, 9. We're going to have 3 times 2, and 3 times 3, or 6, 9. We're going to have 3 times 2 and 3 times 1, or 6, 3. So let's plot those points. I'll change colors. We've got A prime is at 3, 9. B prime is at 6, 9. And C prime is at 6, 3. And I'll draw in the lines. And that's it. That's our image. A lot of kids really like seeing those lines connecting to the center of dilation to the two images. I'll draw those in quick. You really don't need to draw them, but I'll just add them in so you can see them. And there you go. You can see how point B stays on that line. So no matter how I enlarged or reduced the original triangle ABC, the point B would always, always end up somewhere on this line as long as we are dilating with respect to the origin. And you're only going to be dilating with respect to the origin for this class. Okay, I'll try and do this one a little faster, but I wanted to make sure you saw an example of a reduction. So notice, scale factor is less than 1. This is called a reduction. So here we're multiplying by 0.5. Remember, 0.5 is the same as 1/2. So we're going to be doing half of our x coordinate and half of our y coordinate over and over. Okay, so let's figure out what all those numbers are and put them into our final column over here. And now that we have that done, we can plot our points. So W prime is at -2, -3. Just take a look at the graph for a sec before we start plotting. Notice that if this is -6 here, that makes this -4, this -2, 2, 4, 6. So we're counting by 2s. You just have to pay a little attention there. So -2, -3 is actually here. That's W prime. X prime is at -2, +4. Y prime is at 2, 4. And Z prime is at 2, -3. Let me draw in those lines. And there you have it. That's a reduction. Notice our image is smaller than the original figure. Again, because kids like the way it looks, I'm going to add in those lines to connect the center of dilation to all the points. So again, any and every dilation of rectangle WXYZ is going to end up somewhere on those lines. Okay, your assignment is page 511, numbers 4 through 18, evens, and number 23. Good luck. I hope you have some fun with dilations. I always think they're kind of fun, and I will talk to you next week.